Energy is the capacity to do work or transfer heat. And these three things have the symbols E, W, and Q. There are two general classifications for energies, and these are kinetic energy and potential energy. Kinetic energy is the energy of motion. And potential energy can be related to things like position, if you think of something like gravity pulling something down from a height, or it can be something like electrostatic attractions and repulsions. And these electrostatic potential energies are fairly significant in chemistry, specifically in their relation to chemical bonding. One of the guiding rules about energy is known as the first law of thermodynamics. And this law states that energy can't be created or destroyed, it can only be converted or transferred. Much of the way that we use energy in chemistry is through the use of the transfer of energy. And to talk about how energy is transferred, we need to develop some conventions. And the conventions that are used to talk about energy transfer are systems and surroundings. And these conventions are actually pretty simple. The system represents the thing or things that you care about, and the surroundings represent everything else. In the context of chemistry, you can imagine a reaction happening inside a sealed metal container. This reaction gives off heat, and that heat is going to warm up the sealed container. And that warmed up sealed container is actually going to release some of the heat to the air around it, and that air will continue to disperse the heat throughout the universe. And because the heat transfers from the reaction through to the rest of the universe, it can be initially somewhat difficult to identify the system. What do we care about? But the easy thing for chemists is that we're traditionally interested in the chemicals producing or absorbing the heat directly. So in this case, we have a reaction, and the reaction and the reactants and products that are involved are the system. They are the parts that are directly involved in the transfer of that heat. And once we've identified the system, the surroundings are easy. Everything else is the surroundings. In general, this will be how we assign systems and surroundings. We'll find the specific item or items that are involved in the transfer of heat or the work that's done, and we'll identify that as the system, and everything else as the surroundings. There are also a couple of sign conventions that we need to use as well. And those sign conventions involve positive values for an energy or a work or a heat, or negative values for energy, work, and heat. Positive values means the work was done on the system. You can almost treat it like the system gained work, so it's a positive value. Or you could say that heat was transferred to the system. And the negative values mean effectively the opposite. So a negative value for work means work was done on the surroundings, or the system did work on the surroundings. Or in terms of heat, the system transferred heat to the surroundings. That is, the system lost heat, so a negative value goes with a loss. And related to sign conventions are the words exothermic and endothermic. These terms don't relate to a generic transfer of energy, they relate specifically to the transfer of heat energy. And endothermic means the system gained energy, and exothermic means the system lost energy. And if we look at the sign conventions, that means an endothermic process where the system gains heat would have a positive value for Q. And the exothermic process would have a negative value of Q.